Finding relative extrema of a continuous function f on a closed interval a, b. First step is to find the critical numbers of f in a, b. Next is to evaluate f at each critical number in the interval a, b. Then we evaluate f at each endpoint a, b. The lowest of these values is our minimum, and the highest is our maximum. Let's take a look at an example. Let's find the extrema of f of x equals 3x to the fourth minus 4x cubed on the interval from 1 to 2. To begin, we take the first derivative of our function. So f prime of x is equal to 12x cubed minus 12x squared. We find our critical values by factoring this derivative and using the zero product property to solve for x. We take our first factor, 12x squared, set that equal to 0, and solve for x. And that would give us x equals 0. And then we take our second factor, x minus 1, set it equal to 0. And so our next critical number is x equals positive 1. Next, we plug our critical values along with our endpoints into our original function f to find our extrema. In other words, we want to find f of 0, f of 1, and f of 2. At f of 0, we have 3 times 0 to the fourth minus 4 times 0 cubed, which is 0. For f of 1, we have 3 times 1 to the fourth minus 4 times 1 cubed. That gives us negative 1. And for f of 2, we have 3 times 16 minus 4 times 8. And that gives us 16. Here, we find that our minimum is negative 1, which occurs at f of 1, and our maximum is 16, which occurs at f of 2. Note that a critical number does not yield relative extrema in all cases. For example, f of 0 does not give us a relative minimum or maximum. This concludes our example, and we'll see you next time.